Alright, good morning everybody. My name is Dylan O'Loughlin and I did lecture 18.2 on polypropylene fumarate. This is actually, the picture you see is the manufacturing process that they had used to create the microneedles. Let's go back. So the title of the paper was Microstereolithography and Characterization of Polypropylene Fumarate-Based Drug-Loaded Microneedle Arrays. And it was in the Journal of Biofabrication. The scope of this paper was to analyze the mechanical properties of PPF and DEF, as well as PPF decarbazine mixtures, as well as determine the release kinetics of decarbazine. Decarbazine is a drug that is used in cancer treatments. Mostly it's for skin cancer. So the idea was to create microneedles that had decarbazine on them, and then as they decompose in the body they would release the chemical. And the main questions answered in this paper were: can microneedles withstand the compressive forces of skin insertion, and is there a controlled release of decarbazine? For the experimental approach, 50-50 balance of PPF and DEF was used for the substrate, which is the bottom layer that the microneedles were built on. And the microneedles were made from a 1% decarbazine DMSO BAPO weight of the PPF, and also a 2%. The DMSO, it was dimethyl sulfoxide, and the BAPO was, I'm going to try, but bis trimethylbenzoyl phenol phenoxide. Phosphine oxide. There you go. Very good. I'll try. The process conditions examined were compressive loads as well as the decarbazine release profile. The tools that were adopted was a nanobionics tensile tester, which has the setup that you can see here, and a Spectramax M2, which was used to determine the amount of decarbazine released. And the process that was used to manufacture these, they actually had two build plates. One, the build plate on the left would be submerged in the mixture that would be on build plate 2, and as it sunk down into the mixture, it would scan the different layers and actually build the substrate. And then the substrate was only of the 50-50 mixture. It didn't have any of the decarbazine, since that would be on the outside of the skin, and that's not really what you want on the outside. So after the substrate had been built, the second stage would lower, and they would replace that with another liquid with the actual 1% or 2% mixture of decarbazine. And then, because the other build plate was in the same exact position, they were sure that they were getting the accuracy that they wanted, and then they would raise the other one and continue printing. So the key results from study 1 was: can the microneedle withstand the insertion force of 37.6 millinewtons? And as you can see from the graph, it actually was able to withstand over 300 millinewtons. So in conclusion, the microneedle was more than capable of withstanding over the 300 millinewtons of compressive force. And the key results from study 2 was: can decarbazine be released at a constant controlled rate? And as you can see from the graph, for the first 7 days, there's actually a burst period. While it starts to decompose, more and more and more of the decarbazine is released. It's not really uniform. But over the course of the next 5 weeks, it's a much more linear release of decarbazine. So they concluded that after the initial 7-day burst period, the decarbazine could be released at a constant rate. So the key conclusions from the paper was: microstereolithography is a good process for producing micro-scale medical equipment. Microneedles made from PPF, DEF using this process are capable of withstanding the insertion forces of the human skin, and microneedles are capable of controlled release of decarbazine after the after the original 7-day burst period for at least 5 weeks. My personal critique of the paper was it was very informative and well constructed. It was very long. a lot of big words in there. But besides that, I really liked it. I thought it was very interesting. They actually go into a lot more depth in the paper. I would have liked to see their ideas of how this could be used in the future, because the way that they actually tested the release was putting it in a solution and letting it dissolve and pulling out that solution every 7 days and measuring how much had been released. So it'd be nice to see if they were planning on doing any further studies in the future.